Hi, my name is Mithil, and for my final project, I've worked on a chatbot model. So basically, the aim of my project is to create a chatbot using sequence to sequence model using TensorFlow. And I've trained it on the Twitter corpus dataset of 2016 with 700,000 lines of tweets. I'll quickly show the dataset, the Twitter corpus. It contains 700,000 lines of tweets with their reply tweets. I'd like to jump to my model. So this is the sequence to sequence model. In the sequence to sequence model consists of two recurrent neural networks, the encoder and the decoder. The encoder reads the input sequence and generates a context vector or the thought vector. And based on this context vector, the decoder generates the output sequence. So this is the brief overview. Also, the first layer is the word embedding layer that is used for learning dense representations of words. I've also implemented attention mechanism to focus the importance of certain words in the sequence. I'd now jump to the code in the Spider. So for this project, I've created three files: the main chatbot file, the sequence to sequence model file, and the data pre-processing file. The data pre-processing file, like the name suggests, contains the pre-processing of the Twitter data. So I've created the vocabulary size, the maximum and minimum number of length of the questions. So in this, we basically split the sentences, then we remove unnecessary words which are not in the vocabulary. We create the index to word and word to index dictionaries, and also filter out too long and short sequences which might overfit the model. Then for further data pre-processing, I've converted the list of items to list of indices and added the zero padding. I've also handled the unknown words by the U and K keyword like mentioned above. And over here in this function, we've just implemented all the other functions that I've programmed above. That is filtering out unnecessary characters, filtering out long short sentences, converting list of lines to list of words, and adding zero padding. Now jumping to the main sequence to sequence model file. So this is the main model. Over here, we've added the encoder inputs, the labels, the decoder inputs, and the basic LSTM cell. Basic LSTM cell is wrapped in the dropout wrapper. This is the basic cell. And we've created a stacked LSTM by adding multiple cells together. Then this is the building of the sequence to sequence model. Then for training, I've also built a loss function using the optimizer, RM optimizer. Then we've then over here we are running a batch for training, and we're evaluating the batches. Then here we are finally doing the actual training of the model for the number of epochs. We are saving the model after every epoch so that later on we can restore the model from that epoch. Here we create a session and initialize variable. We're running the epochs, and like I just said, we're restoring the model from previous training session and storing them as checkpoints. And this is the final prediction function. This is the main chatbot file which calls the two other classes. So we have the data pre-processing, we're importing the data set, the embeddings, and the finally building the sequence to sequence model, passing the parameters. Then we have loading the weights, the pre-trained weights, and running the session and getting the predicted answer. Now, before going to the output, I'd like to mention about the training. Since training this sequence to sequence model required heavy processing and computing power, which would not have been possible on a normal computer, I've used Google Cloud Platform. Due to the time and monetary constraints, I couldn't train the model for longer times, but I just quickly show this. Yeah. So this is the Google Cloud Platform, wherein I've created an instance as well as the storage bucket. So in this storage bucket, I've uploaded my Python files that'll, and then I've later created a virtual instance. Just to give a brief overview of the virtual instance, it's a deep learning image by Intel with 4 NVIDIA Tesla K80 GPUs and 16 CPUs with 60 GB RAM and 50 GB SSD. So this virtual machine was very helpful for training, for faster training. And this is just a shot of the virtual machine training my model. And as you can see, it took a lot of time for the training. Then after downloading the weights again, we run this, we run the output over here. So this is the chatbot model. I'd like to say hi. How's the weekend? So like we can see, the chatbot is generating very similar responses to what the user is saying. And this is all being generated by the sequence to sequence model with the help of the encoder and the decoder. So although the accuracy over here would not be 100% because of the, like I said, the time and monetary constraints for training the model, but if we train the model for further, we could improve the, this chatbot to better respond. And thus, this is my chatbot model for my final project. Thank you.